And welcome everybody to today's Cosmology segment. Some more interesting stories to cover, and it's frankly difficult to stay on top of cosmology stories. It's part of the reason why we have so many cosmology segments. We're pushing 200 cosmology segments on our playlist, youtube.com/smashomash/playlists. For all of our playlists, we're starting things out talking about the 90-degree bends in the poloidal jets from MRC 0600-399. So you see these jets emanating from the polar field regions of this galactic core. And you can see these jets extend about 16,000 light years, and then they make 90-degree bends. Why do they do it? How do they do it? And what is going on there? Here's an artist's rendition. Now, I don't know why they didn't rotate this, 90 degrees clockwise, so it's in the same orientation as this other image. But an interesting story here about part of a massive galactic cluster, perhaps giving us insight into the way magnetism plays a role in the formation and evolution of galactic-scale jets. Here's an article about it on phys.org. In their astronomy and space section, a new window to see hidden side of magnetized universe. So what we do is we look at the polarization of the light coming out of the jets, and that gives us an idea of the orientation of the magnetic fields. This is Galaxy Cluster Abell 3376. And again, that particular region is known as 0600-399, located about 600 million light years away. Estimated distance. How do we get the T-shape? Well, we're not exactly sure, but that's what makes it an interesting discovery from Kyushu University. So perhaps check out that article on phys.org. The hidden side of the magnetized universe. Next, there's a story about Cygnus X1 in the news today, and you may or may not know about Cygnus X1. We've talked about it regularly on the channel. Cygnus X1 is the first object widely believed to be a black hole. Now, I continue to call black holes massive radio sources. In the mid-90s, I didn't exactly know why some folks, a significant portion of the astronomy community, was referring to black holes as massive radio sources. Even galactic cores, they were referring to the cores of galaxies as supermassive radio sources. And back then, even an astronomy professor, for example, Loomis from Kutztown University, told us that, well, stars aren't electric. You could say they're electronic. And, of course, our regular viewers may be aware that Robitaille's The Sun on Trial 40 proofs supporting liquid metallic hydrogen as a solar building block is a much more likely explanation of what stars are made of. But in any case, an article about Cygnus X1, quasi-periodic oscillations coming out of Cygnus X1. So the constellation of Cygnus is interesting in that there are many interesting objects out there. It's sort of the closest portion of the Milky Way's major spiral arms that are perhaps interacting with our solar system in a direct fashion. The Cygnus arm of the Milky Way galaxy. So the quasi-periodic oscillation was detected at 88 megahertz, and the distance to Cygnus X1 has been recalculated, now believed to be more like 7,200 light years distance as opposed to more like 6,100 light years distance. An article about quasi-periodic oscillations, perhaps giving us greater insight into the behavior of the high-mass X-ray binary, believed to be about 22 times the mass of the Sun, Cygnus X1, famously bet on by Stephen Hawking and Carl Sagan. Stephen Hawking and Carl Sagan bet on whether or not Cygnus X1 would be a black hole. I don't remember who won. And by the way, if you want to watch the X-ray transients of Cygnus X1 yourself, here are the X-ray transients from that. Here's the 30-day chart. Here's the 16-year chart of the X-ray variations, the transient X-ray bursts from Cygnus X1. You can find that and 1,030 other objects monitored regularly at the Neil Gorell Swift Observatory. We show it regularly on the channel. Let's talk about a hydrogen-free supernova. Well, how can that be? You may be wondering, how a hydrogen-free supernova? Isn't there, what's going on with metals? How is that a thing? At the Smash News Network, we're interested in anomalies and facts. So here are some facts. This supernova may have emitted a cloud of hydrogen before it, quote, supernovaed, end quote. However, when it supernovaed, or novaed, or whatever you'd like to call it, it appears to be hydrogen-free. How that can be is not understood and not explainable by the Concordance model of stellar evolution. Yet another article on phys.org in the Astronomy and Space section, the mysterious hydrogen-free supernova sheds light on stars' violent death throes. Now, I don't believe that stars have violent death throes. Stars do violent things. Do they actually die? I have no idea. We've never seen a star die or get born. We've seen stars stop emitting light. We've seen stars begin emitting light. Does that mean they've died or been born? Frankly, the reality of it is, folks, is that we have no idea. So what do they do before they nova? It's not really known. Do they emit a massive cloud of hydrogen? Well, this supernova appears to be interacting with a cloud of hydrogen surrounding it, but did not seem to produce a cloud. In other words, it's high metallicity supernova. A very interesting series of articles today. So we're letting this one scroll in case you'd like to read it. Again, it's on phys.org in the Astronomy and Space section. I'm sure it's all over the Science Wire, as it is interesting to see things outside the realm of the Concordance model, because the Concordance model does not explain all the anomalies that we see, as various aspects of astrophysics, heliophysics, and cosmology are regularly debunked by obvious observations. Speaking of supernovae, here's a noval shell around a Wolf-Rayet star. So we talk about Wolf-Rayet stars regularly in that Cygnus X3 Deneb involves a Wolf-Rayet star. Wolf-Rayet stars are known to produce massive shell-like nebulae around them, as they have very powerful stellar winds. For example, Cygnus X3, the Wolf-Rayet star associated with it, is believed to produce about a 10 times the solar wind speed and density, also the light intensity. Wolf-Rayet stars are very bright, very big, blue supergiants. And once again, this one's interesting in the metallicity. So in the world of cosmology, we refer to all elements that are higher on the periodic table than hydrogen and helium as metals. So lithium and everything to the right on the periodic table of lithium is considered a metal in the realm of cosmology. That all has to do with the standard concordance model. And, well, a reasonable explanation for this is that stars are constantly producing heavy elements on their surfaces and in their atmospheres, but we won't get into that. This is just the astronomy photo of the day, folks. NGC 3139, the new general catalog. This is located at about 12,000 light years in the constellation of Carinae, and that nebula is 75 light years in diameter. Quite a large nebula created by that Wolf-Rayet star in the center. I think it might be this star here, but don't quote me on it, folks. It's the wind-blown NGC 3199. And if you want to read more about Wolf-Rayet stars, go have a look on the Wikipedia page. The massive Wolf-Rayet stars. Very interesting. And that's today's cosmology segment. Thanks for tuning in, folks. Don't forget to check the rest of our playlists, youtube.com/smashamash/playlists. And if you're viewing the video on BitChute, don't forget to subscribe over on YouTube. If you're viewing the videos only on BitChute, you'll only be seeing about 30% of our content.